Welcome to the Accomplished Brain podcast, where we share our passion, knowledge, and experience about the brain and health.
Okay, so I just want to go into, just so people have like a framework on like where that actually is, and they could tell. Let's go back into here. Okay, perfect. So here's our picture. We reference this picture a lot. We call this the neuraxis. And obviously up on top where it says L and R is we're looking at the person like we're facing the person. So that's why the L is where it is, right? Because it's kind of their left. And that's your cortex of the brain. It has 4 lobes: frontal, parietal, temporal, occipital. The bottom here with this blue piece is your sublayer of the brain. That's where your thalamus and your hypothalamus is behind there. Your thalamus is a projection area. So all information except for smell must reach the thalamus before it's a relay area before it hits the brain and cortex. Okay. And then below we have this 3 boxes with a CB on the sides. The CB stands for your cerebellum, which is your coordination part of the brain. The orange is your upper brainstem mesencephalon. Your green is the pons. Your blue is the medulla. That's your brainstem, and that is where a lot of activity happens. So if you notice here, where it's small, but you could see where it says 9, 10, and 11. 10, and these are your cranial nerves. And that's your brainstem, and 10 is your vagus nerve. So vagus nerve is one of your key parasympathetic activation. So we talked about this before, that the autonomics is really important, right? Autonomics, so things are happening autonomically, right? You're not really thinking about breathing unless you're doing a breathing exercise, right? But breathing, heart rate, pulse, temperature, oxygen, those are all autonomic functions, digestion. And there are two areas. Well, there's many areas, but I would say your hypothalamus, okay, which sits behind the thalamus, has some of the parts of the hypothalamus. And I think again, every time we do a podcast, it's interesting that we talk and we really get into this. And I say, oh my God, we should do a whole podcast. We get our topics actually each time we do a podcast, because
right.
you talk about something and you're passionate. You're like, you know what, maybe we should do a podcast, because the hypothalamus is really a cool area. It's where all your hormones originate. So your hypothalamus, some of the areas of the hypothalamus project into the brainstem, for the autonomics. And then the vagus nerve is very huge for the parasympathetic side of the autonomic nervous system, which is the side that usually calms us down, which is the side that, not all, but is a side that many of us, including myself, needs to have that parasympathetic stimulation. Okay. So the thing is, with the parasympathetic stimulation, what does the vagus nerve do? So the vagus nerve is very important for, so we'll say a couple things. One, it's very important for speech, for swallowing. So those are your motor parts of the vagus nerve. Your sensory part of the vagus nerve there's an area called your phalanx, and in your throat, in your phalanx, the back part of the phalanx, they call that the posterior part. The front part, they usually call it anterior. The posterior phalanx is there for taste. Now, taste is really important because taste fires into an area of the brainstem, which is probably, I would say, probably more pons. It's called your NTS, right? Pons and a little bit of the medulla. Your NTS stands for your N as in Nancy, T as in Tom, S as in Sam, is your nucleus tractus solitarius. Now, it's a part of the nucleus tractus solitarius, has an up part and a down part, right? So the up part gets activated usually when you have taste. Okay, so these are afferents of when you have taste. So an example is, you know, so you'll receive taste from the front part of the tongue. That's cranial nerve 7. Okay, you'll receive taste from the back part of the tongue. Okay, that is that's the glossopharyngeal. That's cranial nerve 9, and then you'll receive the NTS will receive information from the back part of the phalanx. Okay. So the NTS is there also to help calm us down, because that's the top part of the NTS. The bottom part of the NTS receives information from baroreceptors. Now, this is very interesting. The baroreceptors are remember Jeff and I talked about the nervous system is all about receptors. It's all about like information receiving and then sending to somebody else and then traveling through some kind of pathway, activating different areas. I mean, that's how the nervous system, it's your electricity part of your body, right? And it's like if you have a Tesla and I'm an Elon. I'm not a Tesla. I don't have a Tesla yet, but it's a car that I desire to have one day. I'm a big fan of Elon Musk, right? And I think what he's doing is all about about being a humanitarian, which is all what Jeff and I are about. And my wife is an incredible lady. So a great mom. So if you look at the Tesla, the energy part of the Tesla is the battery, right? So all the mechanics cannot work if you can't turn the car on, and the car, it's its power. Well, that's the same thing with the brain and nervous system. So the baroreceptors are receptors that stretch, and when they stretch, that's how they get activated. When they get activated when they stretch, and when they stretch, they send an afferent to the vagus nerve, which sends an afferent to the parasympathetic system to calm the system down. Well, the baroreceptors you have, and that's also, so it's basically like your baroreceptors fire, they activate your NTS, the NTS activates your vagus, the vagus activates the parasympathetic system. The NTS, the nucleus tractus solitarius, is, we said the top part gets activated with taste. The bottom part is with these baroreceptors, right? These baroreceptors get activated in the carotid sinus of the neck. So breathing, just regular breathing exercises or breathing during aerobic activity, right? Whether it's walking, running, okay. And then there's these baroreceptors that are in the aortic arch. So the eccentric activity of the continuous running. So what happens is that this is why it's very important. And again, I have another topic that we like to use is brain stimulation looked upon what happens to anaerobic and aerobic activity. So aerobic activity is just continuous training, and what's happening is the blood flow back to the heart, right, and back to the right atrium, the right atrium, right ventricle, to the left atrium, to the left ventricle, and when you're getting this continuous exercise, what tends to happen is that the blood flow coming back to that right atrium, right ventricle, then it moves to it fills into the lungs, and then the pulmonary system, and then the left atrium, left ventricle, and then that left ventricle, what happens is it has to get wider, right? It's not only getting thicker this way, but it has to get wider so more blood could fill the width of that left ventricle, and off of the aorta, there's these baroreceptors, right? And they stretch, and when that stretch sends a signal, okay, it sends one signal to your NTS, the NTS, which is the lower part of your NTS, sends a signal out to the vagus, which then sends a signal out to your parasympathetic, which basically causes these vessels to eventually dilate and causes all this good parasympathetic, really good digestion, motility. So motility means that the migrating motor complexes, so the smooth muscles in your stomach can move the food through the stomach and the tract, right? So, and also, with people with SIBOs, they'll help because the migrating motor complexes can close the ileocecal valve, which is a valve between the small. Hold on one sec. Excuse me. Which is a valve between the small and large intestine. I just need some more water. So the vagus nerve is really, really very powerful, and it could be indirectly activated with all sorts of brain stimulation. So whether you use your eyes, whether you use your vestibular system, whether you use your muscles, the vagus nerve is being activated all the time because as Jeff and I talked about, you could see in our course, it's called Core Concepts in Functional Neuroscience. Functional means that everything is communicating together, right? So one area can influence another, which can influence another. That's functional. So indirectly, if you give an eye movement, if you give a vestibular exercise, if you give a balance exercise, if you give sound, if you give, if you give movements of your limbs, they can indirectly activate the vagus nerve. Now, directly to activate the vagus nerve, what did we say? We said that one could be breathing, right? Humming, gargling, because there's also a gag reflex. So also when you gag, so if you stick something down your throat, right, and your palate, your dome comes up and you gag, that's another direct way of activating the vagus nerve. And then obviously another way that we wanted to talk about is using a TENS unit with an ear clip, because the ear clip, okay, and I need to come back and do a little more research of why everything's on the left-hand side, but it is on the left ear that we usually activate the vagus nerve. And we have the tragus, which is here, and up here we have, which is in the ear. And usually the ear clip, the fat part of the ear clip goes on the inside of the tragus, or we have up in the ear here called the symbicontia. It's a little bit higher of a stimulation, and it's the auricular branch of the vagus nerve. And I've used it with myself. I've used it with family. I've used it with family, friends, clients. I use the vagus nerve a lot, and I use it, and Jeff could probably say the same way, is that I use it.
Better right here.
And I used it today. I was having, I don't know, I think I would, I haven't been as strict with some of my foods in the last little while. I mean, I've been good with my diet, but I've been eating some foods that I think my stomach has been reacting to, whether it's dairy, and it's my own being. And I realized today that I needed to get back to using the vagus nerve. So I used 15 minutes probably this afternoon, and I'll probably use 15 minutes tonight. And what that auricular branch did for me was, one, there's a cholinergic, so choline, right, is the neurotransmitter. It's the chemical that stimulates that pathway. So the cholinergic anti-inflammatory reflex, which basically activated a reflex that decreased the inflammatory response in my digestive, and obviously the immune cells sit right behind, 60% of the immune cells sit right behind the digestive wall. So if here's the wall, 60% of your immune cells sit behind that. So that is just an amazing thing. When you do vagal nerve stimulation, you can have, digestive, but you could also have immune modulating effects, because a lot of the immune system, when you're modulating the immune, it's decreasing inflammation. So you could do that with the immune system from let's say, your fish oil, your vitamin D's, your resveratrols, your curcumins. You can use those type of things, but also you could come in and use vagal nerve stimulation. And I do that a lot. Now, the vagal nerve stimulation, as Jeff could say, it has an nociceptive response. So that means it can modulate pain. Okay. So that's another thing. So inflammation, pain, improved swallowing, improved speech. Okay. The other things that we've seen and why pain, one of the reasons is that a neurotransmitter that is heavily used to modulate pain is serotonin. Well, serotonin is like, wow, we were talking about serotonin when we were talking about sleep, right? Because if you think about it, what did we say? We said, the key factor in sleep is what? We said that one of the things, your cortisol has to be low. Your serotonin is a precursor to make melatonin, right? So serotonin and melatonin have to be high with sleep, and your cortisol has to be low. So the thing is, if you need melatonin, you need a precursor to make serotonin, right? So he said that serotonin is important for mood. It's also important for modulation of pain, and it's also important for your first levels of dulling the pineal gland to fall asleep to make that increased melatonin, and you're hoping your cortisol levels are low. So there's a lot of things that we do. Obviously, also the vagal nerve stimulation to activate the parasympathetic system is going to overall calming effect of the nervous system. So what happens when people have, and I can take this off, what happens when people have seizures, right, or headaches is basically they can't come back, the nerve cells can't come back to that -65 rest. So they're spontaneously firing all the time. That's what your seizure activity is, right? So how do you get down to the neurons back to that -65 rest period? Well, you need to activate the parasympathetic system. Well, we talked about green leafy vegetables, right? Your rugulas, your kale, your spinaches. We talked about that, right? Because they have high magnesium. Magnesium inhibits the sympathetic system, and then potassium activates the parasympathetic system. Well, another way that we could activate the parasympathetic system is through vagal nerve stimulation. So I just think that, in our model, we are probably more, Jeff and I, more exercise stimulation based, but we couple the nutrition. Now, that doesn't mean that it can be the other way, where somebody does more, nutrition, they're more into functional medicine, and they do a little bit of stimulation. That could work very well too. I think it's both sides. It's depending on, where your comfortability is. I think Jeff and I think nutrition is extremely important, extremely, food, supplements. But I think our both of us probably come from a more exercise base. So we're probably more looking at it from the stimulation, but we recognize how important the nutrition and the supplements are. But so the vagus nerve is just huge. Again, to review, the vagus nerve, the branch that we use is in the tragus of the ear over here, or the symphoconcha up here, but mostly the tragus. It's on the left side. I need to find out why it's only on the left side. But right now, I need to research that so I can get back to all of you guys, and I will, or Jeff and I will. And the vagus nerve, very important for swallowing, for speech, and then, activating the parasympathetic nervous system, which helps calm the system down. It's also really good for improving your digestion, the migrating motor complexes, and the motility. So being able to move the food through your digestive tract, also to suppress any inflammation in the digestive system, which we said the immune cells 60% of the immune cells sit behind the digestive wall. So it's going to help modulate the immune system, because a lot of the immune system modulation is all about suppressing inflammation, which is in general all of modulating most disease is finding where your inflammatory, your inflammatory areas are and plugging that. The other thing is that it can help increase serotonin levels, which again, the serotonin can help modulate pain, mood, and obviously we talked about sleep. Um, the other thing that it does is it can help. There's a lot of research on improving headaches, seizures, and also your neuroplasticity. So what happens is that the brain works with one. You have certain areas that get activated, but then you have a group of areas that get activated, which they call that neural networks. And what the vagus nerve does is, so whatever type of rehab you're going to do, it helps the whole network around where you're stimulating. So whatever rehab you're going to do, the rehab can improve its ability to plasticize and make change through activating vagal nerve. Now, this is very interesting. I've used with a lot of stroke or people who have tumors and get spastic, and I've seen that whatever rehab we do, that their motion in their arm or hands will vastly improve, much better by just not only doing whatever rehab we gave them, but doing the rehab with the vagal nerve stimulation. I've seen it, and I've had colleagues. I'm working on a case now with a colleague that is in Atlanta, very good guy, Tony Davenport. If you're in Atlanta, look him up. He's very, very good for nervous system, peripheral, for spinal cord injuries, for strokes. Very, very good. And I'm working a case with him, and he's really good with the bioelectrical physiology, so electrical stim, and he has just great units, and he uses the vagal stim all the time coupled with the brain exercise software that I have conceptually designed. So it's working out really well. So the other thing is neuroplasticity. So there's so much involved